continuous pipeline.
Cool. I'm a senior software engineer at Zignal Labs, and I'm going to jump right in here. So essentially, we're going to start about talking about what Zignal Labs does and how we help organizations be more data-driven. We're going to follow that up with why we felt it was necessary for us to rebuild a sentiment pipeline or a sentiment analysis API, and then talk about iteration and how essentially we don't get things right the first time all the time, so iteration is really important to us and how we do this with continuous delivery. And then we're going to talk about developing a pipeline from labeling all the way to making inferences. So I'll apologize in advance. You will see some Python here, and we will see Python in production. Not the greatest thing, but it's a little bit of the reality of if you have a small team today and want to get something working in the real world. So what we do at Zignal Labs, essentially we provide our customers with real-time insights across the media spectrum to help them make more informed decisions. Basically, today we provided organizations a platform to do things like see the share of voice against their competitors after a major product launch, or understand the health of their brand in real time, or even watch news spread across publications after a big announcement, or even stop a crisis early through the identification of a trending story. Essentially, we're really here to support these teams, whether it's marketing, communications, executive teams, or even investor teams, across their entire workflow, from understanding the situation to action. So when we start to look at what different types of analysis we care about Zignal Labs, we can kind of break it up into these main categories, where essentially we start with descriptive analytics, and we start to understand essentially what's happening right now, and we can say what media outlets captured my brand in the last 3 weeks, or how many mentions did my brand receive in October. From there, we can go into diagnostic analytics, where we try to understand why what actually happened took place. And this is where we get questions like, what is the sentiment across my earned media? Or what events drove the conversation to get that many mentions? And we can go even a step further here and talk about predictive analytics, trying to understand things like, what is the likelihood this story will go viral? Or if I don't do any intervention, how long will this story dominate the conversation? Or even, how will my content be received? And lastly, on the final kind of tier of this, where we talk about action, we can talk about prescriptive analytics, where we can start asking questions like, how should I craft my messaging to leverage current events to get the maximum impact? So we have all sorts of great questions we can solve here. Why in the world are we talking about sentiment? When we start to build out a solution in-house, we have to go through a lot of different tasks here, from understanding the product to creating kind of the infrastructure and seeing what's out there to leverage open source technologies, and then we have to maintain that code. It's a lot of work, and there's open source APIs that will basically do all that work for us, and we don't have to worry about it. Well, the answer is we started with the kind of pay-for APIs, and we use that in our platform, and we got a lot of customer feedback. First, they said that sentiment was really important to them, and it mattered. Second, they said that the solution that we had wasn't working, and we needed something better. So we went down this path of trying to understand what about our data was so special, or what about their perspective was different to where these sentiment solutions that were already available weren't working for us. So we dove into the data. And sometimes it's really obvious about what sentiment is, like in this case, where we've got a great group of people making the world a better place. Obviously positive, no question about it. But other times it gets a little bit more complicated. There's this notion of sentiment around emotion, where sentiment is defined essentially by the emotions that are portrayed. And in this case, sadness, it's a negative emotion, and that becomes the sentiment. But there's also another perspective here that we can take, where we can ask ourselves, well, what does this say about John McCain as a person? And lastly, we noticed that a lot of our content was a straight statement of facts. So when you're looking at this from this perspective, it's a kind of news outlet that's just trying to be unbiased and present information. But the fact is that when people see information that happened, it could kind of taint our perspective about our companies, about these companies that we're reading about. And this is something that our customers wanted reflected. So in this example, what does this statement say about Lehman Brothers? So we kind of took this all in mind, and we came up with several objectives that we wanted to meet on a sentiment rebuild. Essentially, first, we decided to redefine the problem here, where instead of having a generic idea like sentiment, where there's lots of different perspectives about how to score it, we went for this polarity of reputation, essentially trying to understand how a particular statement impacts or what it says about the image of a brand or a company. The next thing we wanted to tackle was data skew. Essentially, we've got a lot of different customers monitoring a lot of different things in our platform. And some of these things have a pretty high volume, and some of these things are pretty small and have hardly any mentions about them. But in our system, we get customers that look at these small streams on their own. So if we build a classifier that does well on the aggregate, it can completely ignore the case of the minority streams, and it'll have awful accuracy on that. So to address this, we went with equal sampling across all the data streams in our platform. And lastly, we wanted to do something about this trust and transparency problem that we had. We kind of came to the conclusion, or we felt that there were these expectations that sentiment was perfect all the time. And we wanted to kind of do more to expose the fact that this is a machine learning solution, and it's not going to be perfect all the time. So we wanted to offer this ability to kind of, next to your historical sentiment charts, where you see positive, negative, neutral, and number of mentions over time, you can also see this, well, here's how accurate our sentiment is, whether that's 70, 80, or 90% accurate. So this is kind of the high-level solution that we're going to be walking through, essentially starting with Elasticsearch and starting with labeling and going to Amazon SageMaker. We'll be jumping into each of these technologies a little bit more in depth in case you're not all that familiar with it. So throughout this whole process, essentially, we like to take small steps so we can get things out there very quickly and continuously improve. So at Zignal Labs, we do a lot of continuous delivery, where essentially we codify everything in our deployment and make it very easy for us to continually improve on solutions moving forward. And additionally, we have some Python here, which, as you know, kind of runs into scaling issues when you start having massive Python projects. And we would like to keep things small. So we have this deployable project pattern, which allows us to do small projects, basically microservices, and still have the leverage to be able to kind of reuse all this infrastructure code. So it's easy for us in a few lines of code to say, I want another Lambda, or I want another Elastic container service to where I can deploy my Docker image to. Or I want even another API just to spin up, using all these kind of common deployment patterns that we have. In addition, like I mentioned earlier, everything in our pipeline, or everything in our deployment is pipelined. So there's no tribal knowledge around how do you deploy this into production, or how do you deploy this into staging, or what should I check after I deploy. It's all codified, which is absolutely fantastic for us to make it easier for us to iterate. So essentially, we have this method of developing code for us. We have our ideas of how we want to make sentiment better. And for all of this, the kind of key foundation for machine learning right now is labeled data. So we need a massive amount of labeled data. And additionally, we decided that we want to continuously have this so we can continuously provide feedback for our customers about how accurate our solution is. So I work on a team of 5 people. And if we decided to try to label this data ourselves, we'd probably spend the next 8 months labeling data, and then we'd spend the rest of eternity trying to maintain the solution to provide those labels. So we decided to leverage a crowd solution, where essentially Amazon Mechanical Turk has basically service where essentially there's thousands of people out there in the cloud just willing to accept work for us. So we have a process every day that wakes up and samples our Elasticsearch data store, which is basically where we have all our data normalized across many different sources, whether it's Reddit, Twitter, news and blogs, broadcast even. And we take that data and then transform it into easy questions that a single Amazon Mechanical Turk worker could answer for us, and publish it into that cloud. And then we've got a separate process that wakes up every so often and collects the complete questions, where a complete question is one where 5 different workers have answered the same question, and it infers kind of a best fit answer there, trying to kind of guess about worker qualities and worker biases using an expectation maximization algorithm. And it publishes these kind of best fit answers into our Elasticsearch cluster so we can have that transparency with our customers and use it to drive our front end or our platform itself, as well as to S3, so we can continuously improve our model going forward. So an important aspect here is our labeled data quality. Essentially, our model is never going to be better than the quality of our underlying labeled data. So we spend a lot of time trying to understand how it was going wrong and how we can improve it. We care a lot about sources of disagreement between both our internal labels at Zignal Labs in the crowd, and between the crowd workers themselves. And we kind of narrowed down this disagreement into several kind of key tasks here. The first is task ambiguity, where essentially not everyone kind of understood the idea of reputation polarity up front, or even there were times when our instructions didn't quite align with the data that people would see. So we did things like iterating on our instructions to hopefully make things more clear, and adding extra options for people to answer. For example, we added multiple polarities for cases where essentially there was both a strong positive and negative answer offered at the same time. So we essentially saw a coin flip about which one people were choosing. The next kind of case that we came across was worker perspective. As you noticed, we try to get sentiment on statements of facts, which some facts can be kind of polarizing depending on people's prior opinions. While this is very useful, and you probably could dive into this for quite a while, is about understanding how people react on kind of a segmented fashion. For us, we're not there yet, so this is kind of a source of error in our models at the moment. And lastly, there's worker quality here. Not all workers are going to be as honest about answering questions up front, and they're not going to take the time to actually read through the data that they're answering for. So this is something we had to be vigilant and filter out and kind of understand that this is happening, and to a certain threshold we're okay with it, but below a certain threshold we weren't. So the great thing about the process that we set up here is we were doing a small amount of kind of labels daily. This means that we can kind of start to understand what's going on and then correct the situation going forward. After the first 50 or so days of doing this, we looked back and saw essentially how many workers were coming back to us, and if there was a chance that we could start to work with these workers to make them better and make the whole solution improve for us. And we found that roughly 50% of the workers came back 10 or more days, and it's gotten even better since then. So what this meant is we could start investing in workers with feedback, where essentially on a weekly basis we email them back saying, here's what you answered for us, and here's what our best fit answers are. And while we realize that these aren't 100% correct, you can kind of understand if there's a pattern here, that maybe you should go back and read the instructions and kind of understand how to improve the situation going forward. We also give them like an overall accuracy metric, saying this is how good you've done over your recent tasks. So we have all this label data, and we're a really small team, and we need to somehow create a machine learning model. Right now, the state of the world is that there's a lot of really great frameworks written in Python. So we picked a few of those off the shelf: Keras, Tensorflow, NLTK. If you look at any of these frameworks in the basic examples, you'll probably see a sentiment algorithm in there. A lot of them use bidirectional long short-term memory networks. And that's kind of what we picked up. For news and blogs, we kind of leveraged our knowledge of what our customers were looking at in their data stream to figure out which specific sentences were relevant to our customers. And we filtered those sentences out and then sent them through a neural network to get a final sentiment value. For Twitter, we did something slightly similar, where we just used the whole body, but we also included the link title, because sometimes we found that that was pretty determinative in understanding the overall sentiment on the tweet itself. So we have these wonderful Python frameworks. They run great locally. And we have this real-time data enrichment pipeline. Somehow we need to union the two. Currently, we have a bunch of data collectors written in NiFi, and that goes into Kafka. As many people have seen architectures like this before. And our streaming and data enrichment is written in Storm with Scala. And this is kind of where we wanted to integrate. We already had this pattern here established where we work with a lot of third parties, and they provide REST APIs for us to integrate with. And that's kind of the path we wanted to take here to be kind of a seamless replacement, as well as enable two different teams to kind of work on this project, where this real-time data pipeline is managed by a different team than kind of the data science-y team where I'm at. So we looked around and found Amazon Sagemaker to kind of try to handle the Python code that we have into a production environment. So we're going to dive more into each of these, but essentially we have Lambdas handling each kind of section of the job. So every day we take those new labels that we have on our S3 bucket in conjunction with an initial bootstrap labeling set, and we train a new model using kind of the parameters that we've best fit in the past. The model is all saved in a Docker image that comes in, and essentially Amazon, the SageMaker, worries about spinning up the hardware for us, running the model, and we save out the final results of the model to Amazon S3 as well, where we save essentially how good this model did on its cross-validation, the model weights, and the encodings from inputs and outputs to vectors. The deployment process is somewhat similar. So we had to be really careful here because essentially if we change our model or change something significant in our code, there's going to be a huge time lag between the time we released that and the time it hits production. Because every time we make a change, we have to essentially train a new model. And once that model is trained, we can finally put that into a production API. So we wanted to be extra careful here about how we were doing our deployments. And that's why we went with canary deployments, where essentially our models are introduced as a 5% variant, meaning 5% of the traffic is routed to that endpoint. And we monitor this over the first 15 minutes or so of it being introduced. And if it passes our health check, which the best we can do right now is checking for 500 replies, then we promote it to full 100% variant, meaning all the traffic is routed to it. So the actual API here was just done based on provided architecture recommendations. Basically, it's Flask app, no kind of awful with Python, but basically two different options here. One is for predicting Twitter, and the other is for predicting long form. And we just go ahead and return those predictions. This all runs within Sagemaker, so we have auto-scaling rules set up. So if we get a huge influx in traffic, it worries about scaling it up to the appropriate levels. And the underlying implementation here is in Keras and Tensorflow, so it runs pretty quickly, because the majority of the code doing work is written in C++ and C. So the result of all this work is that we saw a huge improvement. Essentially, at Zignal Labs, we care about monitoring our solutions pretty tightly. So we have understanding of what the previous solution was, as well as what the new current solution is. And we saw about a 25 to 30% accuracy improvement. Now, this isn't to say that these public APIs are bad. We've done a lot of things that make this not a fair comparison. We've changed the problem that we're solving, and we have an entirely new data set with new distributions to kind of use in our training model. And this is the same thing that we're using to judge the accuracy for. So what this really means is that we're 25 to 30% better for our customers, which is good for us. And secondly, we've also included a bunch of metrics here around our workers and our worker pool to kind of make sure that, or try to make sure to the best of our ability that their worker quality does not degrade over time. We still occasionally go back and try to do hand labeling comparisons between their quality and our quality. So summary, essentially, nothing's ever done. There's always more work that can be done. And for us, one of the huge things here is that inclusion of relevance inside of sentiment analysis is still heavily kind of underserved. Our customers come to us with a certain perspective, and they expect sentiment to be done in a certain way according to their perspective. And we have to kind of understand what that is and come up with kind of a best fit for that. So while their solutions like entity-based sentiment goes away to that, they still just want to see one sentiment value. They don't want to break it down to the entity level. And lastly, and also, model exploration. We follow the typical model for data science where you spend 99% of your time doing data preparation and gathering labels and 1% actually doing a model. So there's probably a little bit of room that can be squeezed out of that in terms of improving model performance. So the kind of cool things that worked here is that we have this continuous ML pipeline that will continuously get better over time, which is absolutely fantastic for us. And it's really hands-off as well. We don't actually have to go back to it too often or at all to keep it up and running and make it get better. We did actually put this through a bunch of customer trials as well before we pushed it into a full release. And got a bunch of positive feedback there. And now that it's in more of a full release, we've seen that essentially the customers that were doing the most overrides in our system are now doing 60 to 90% less overrides for sentiment, which is totally awesome that they no longer have to do this, no longer have to waste such a massive amount of time hand coding every story. And also, we got a lot of cost savings compared to the APIs that you pay for here, enough to hire a few more engineers. So on that note, we are hiring. So if you're interested in working in data pipelines in Scala or machine learning, check out our website or email me or talk to me after this. Thank you, guys.
Thank you, Jeff. It's impressive to see somebody re-implementing a whole NLP pipeline and actually getting that degree of improvement in customer satisfaction.
Cool.
It shows how ungeneric the problems actually are. We do have time for questions. And
Hello. Thanks for the talk.
Yeah.
Could you expand a little bit more on what you meant by manual overrides of sentiment?
Sure. So essentially, we understand that sentiment isn't perfect in our platform, and we get customers that care a lot about sentiment. So I've heard of things like people tying people's bonuses to sentiment. So what this means is that they want to make sure it's really accurate when they do the reporting in our platform. So they will actually go through and on an individual story basis or on a rules-based basis, they will say that this story in our platform is marked as negative, but actually it should be positive. I'm going to apply that, and now it's going to be in all the reports that I generate from now on. So that was a good indicator of how satisfied people were kind of feeling with our sentiment solution. But at the same time, because we had this kind of rules-based method of allowing that to be done, it was a little bit difficult to turn around and use those for labels themselves, because we don't really necessarily know the accuracy or kind of how well that was done, especially because many different customers do it in many different ways. Well, thank you guys.
Thanks again.